Welcome to Math 1324, Section 8.5. This is our last section on probability. Here we're given a probability distribution. So this table here is a probability distribution. We have a random variable x. So x shows you all the things that x could take on. So x could be minus 4, x could be 1, x could be 4. This row shows you the probability of that particular x. So the probability that x is minus 4 is 0.3 or 30%. The probability that x is 4 is 0.2 or 20%. So what they want us to do is to take this probability distribution and find something that's called the expected value. The expected value is essentially the mean or the average of the distribution. How do we get it? Well, we simply make one more row over here, and the row is you multiply the x with its probability. So minus 4 times 0.3, 1 times 0.5, 4 times 0.2. And then you add them all up and you end up with 0.1. So this is the expected value or the long-term average. It typically is applied to games of chance, as in question 2. In question 2, we have a hat, and this hat has in it a $5 bill, a $10 bill, a $20, and one $100 bill. So that's all that's in the hat, one of each of these. So the number of things in the hat in my sample space is only 4. So my distribution consists of the values that x could be if I reach in and grabbed that particular bill. And so what's the probability that I pick a 5? Well, there's only one 5 in there, so 1 out of 4. The $100 bill, similarly, 1 out of 4. So to get the expected value, I make one more row, multiply together the corresponding x and probability. So 5 times 1/4, 5/4, 10/4, 20/4, 100/4, add them all up, and I get 3375. So you say, what? There's no bill in there like that. That's why this is called the long-term average. If we do this experiment one time, you may get a 5. We do it again, you may get a 20. We do it again, maybe you get a 100. And we do it again and you get a 5 again. If I average up all of these values that you are getting over 100, 1,000, a million times of doing this, in the end, we'll essentially be earning $33.75, even though there is no bill like that in the hat. All right, in question 3, we're going to pick a card from a deck, and if it's red, we're going to win $35. Otherwise, we lose. Okay, well, let's see. What's the expected value? Well, what can happen? What are my values for x? Well, I could win and I get $35. Doesn't cost me anything to play the game. I just win or lose. And if I lose, I get nothing. All right, well, how do I win? Well, I get a red card. Well, how many red cards are there? Well, we know that the probability of a red card is 26 out of 52, which reduces to 1/2. Well, if I win when I get a red, that means I must lose when I get a black, and there are similarly the exact same probabilities. So the expected value, I multiply together x and p of x. I get 35 over 2 plus 0, and so $17.50. So again, this is sometimes I win $35, sometimes I lose, sometimes I win 35 a couple times in a row, and sometimes I lose a lot too. So, but the long-term average is $17.50. In question 4, we have a coin. If it turns up heads, I get $1, and if it turns up tails, I lose $1. All right, and they tell me the probability of heads is 0.35 and the probability of tails is 0.65. You may say, well, I thought it's supposed to be half and half. Well, this was an unfair coin. Something's wrong with the coin, so it's not balanced. All right, so let's see what happens. Well, I can get a heads or a tails. I can win $1, lose $1. Probabilities are there. I simply multiply these together and add, and so the expected value is minus 30 cents. So in the long-term average, I'm going to lose 30 cents. All right. Let's see, on question 5, on 3 rolls of a single dice, I'm going to lose $19 if a 3 turns up at least one time, and otherwise I'm going to win. Okay, well, first off, how many things are in this sample space? Since I'm rolling 3 die, well, the number in my sample space is 6 times 6 times 6, because a die has 6 sides and we're doing this 3 times. So there's 216 possible outcomes. That's a lot. So it could be 111 all the way up to 666. 216 of these if we were going to list them all. Now, so that's why all the probabilities are over 216. Now, how do I get at least 1 3? That's the tricky question here. At least 1 3. So I could have a 3 followed by 2 more numbers. I could have 2 numbers and a 3 in the middle. I could have 2 numbers in the front and a 3 on the end. So you see, there's my 1 3. Now, how many ways for there? Well, see, there's a 1 because this has to be a 3. There are 5 more possible numbers there because I'm considering that they're not 3. So there's 5 numbers left, so 25. 25 again, and 25. So for 1 3, that's 75 of them. But they said at least 1 3. It could be 2 3s followed by something else, 2 3s followed by something in the middle, something starting it followed by 2 3s. Well, how many there? 5, 5, 5, 15. And there's one more possibility. I could have all 3s, and there's only one of those. So there's 91 ways out of 216 that I could lose $19. Well, if there's 91 of those, then 216 minus 91 gives me my 125. To find the expected value, I simply multiply the corresponding x and probability, add them all up, reduce to a decimal, and I get minus $3.95. And finally, in question 6, we're going to draw one card. If it's a king, I win $10. Otherwise, we lose $2. So x can only take on two possibilities. How many kings? Well, 4 out of 52, which is 1 out of 13. How many ways to not get a king? All right, well, that's 1 minus 1 over 13, which is 12 over 13. So again, multiply them together, add them all up, and I get minus $1.08. Again, a long-term average. Sometimes we're going to win $10, sometimes we're going to lose $2. But in the end, the long-term average is we're going to lose $1.08. That's why if you go to Las Vegas and you win, stop. Because if you keep winning, eventually you're going to lose because the game favors the casino.